In this chapter, we're just going to get started with basic, very simple classes. Much of this will be similar to what you saw when you looked at Java classes. A lot of the ideas are pretty similar. There are some big differences. We're not going to dwell on the differences too much right now. We're just going to set up some very simple ones. Okay, so let's take a look at classes. Very similar to structures or structs. The one big difference is that C++ classes, just like Java, has member functions and not just member data. And this is integral to object-oriented programming. That is, you have a class with member data, that is, it holds some data, it holds a whole bunch of data, encapsulates it in one thing, and then also you have some actions that you can perform on that member data. Those are the member functions. Okay, so in object-oriented programming, we focus on objects. We try to make everything into objects, and each object contains data and operations. The data is the member data or member variables, and operations are the functions. In C++, variables of class type are called objects, just like in Java. Here's a nice simple example. Defined very similar to structs. We say class day of year, and we use the familiar visibility modifier, but note this is just a superficial difference, but it's an important one. We don't say public for each function as we do in Java. Instead, we say public colon, and then there's everything that comes after that until the next visibility keyword is public. So this is all public. We can have, typically we have public, and we usually only have methods. Remember that as with Java, unless there's a really good reason, make all your data members private. So what you really should do is have a private here so that all of the data members like month and day, those are kept private, and those are usually declared after all the public things. Okay. One other thing to note is that typically functions will have no method body in the class declaration. So in the class declaration, no method body. So it does not mean that this is an abstract data type. Abstract class. Because in Java, you're probably used to this. You set up a method with no method body, then by default that is an abstract method. And then if you have at least one abstract method, your class has to be abstract as well. There's all these little things about abstract classes that I hope you've seen. But this is not an abstract class. This is how you declare the class, and then you have a definition for each one of these methods. So this is just a function prototype or declaration. Later on, somewhere else, we'll have the definition of each of these methods. In this case, it's only one, and so we will see how to define methods. Okay, so how do you declare objects? Same as all other variables. You have the name of the class, and then you have the name of variable. So today is of type day of year, and day of year, we're assuming it's a class. Could also be a struct, but this will work. Birthday is also an instance of the day of year class. So, and objects include data and operations. Data is members. So for example, in here we had month and day, and we had the method output or operation called output. Okay, so I'm going to compare structs and classes. Let's take a look at this simple example. I'm going to try to make this a little bit more compact, just so that we can see everything easily. Normally we don't do this with struct definitions. I'm only doing this so that we can see everything in one page full. Okay, so we have a struct x and a struct y. And notice they're just about the same. But here's a, let's say we can pretty much use the same kind of structure code to set up a class. Change the struct to a class. In a lot of situations it'll work. It'll work fine. No problems. Let's see if you will have problems. So now I changed the y. All I did was change the y from a struct to a class. Compile it. I do get some error messages, and this has to do with the fact that in structs, any data members that you see here, if you do not say what the visibility is, it defaults to public. In classes, it's just the opposite. It looks very similar, right? But there is an implicit private over here, and just because we used a class. So struct, once again, implicitly, all of these data members are public. In classes, the exact same thing. Is the opposite, it's private. So it turns out there in Java, so here's another difference between Java and C++. In Java, if you do not say whether it's public, private, or protected, there is a package private visibility. There is no such thing in Java. I mean, there's no such thing in C++ because there is no such thing as packages in C++, but there is an implicit visibility. So here, this is the same as saying private. So whether you say it or not, there is actually a private section. Okay. Now we can, remember, this is not a good thing to do. Any data member that you set up in a class should be private, but we can make them public. And if you do that, try to compile this, let's see what happens. It works. So let me do that again. If you take this out, no visibility, remember by default it is private. So if you have a private data member, you cannot assign them values. You have to use something like a constructor. And if you used classes in Java, you know what constructors are. So this is although it's not completely obvious, you can take this as proof that if you set up a class and don't specify the visibility, it defaults to private, which is why this doesn't work. And you can make it public, which you should not do for data members in general, but here we're just looking at the syntax. Notice that everything works. Okay, so I'm going to change this ever so slightly. I'm going to say y. It's not that. And I'm going to get rid of this. Simplifying my code, just looking at a single struct x, a class y, where I've made it behave just like a struct by making everything public. And let's see if this will work. Compiles, and when we run it, notice that we get the same thing that we would have gotten if this was a struct. So try that out. Set up a simple struct and a comparable class. See what works, what doesn't. Notice that you'll have to have this public so that you can access these things. As soon as you make this private or just take out the visibility, of course we will have problems. We cannot access private data members. Compile it and we will see errors over here when we are initializing this object, and also we probably, if we didn't have errors here, we would have gotten errors here because x and y, the data members x and y of this class y are private. Okay. So it's another thing to note, if you get an error message here and none over here, does not mean that there's no errors in here. Sometimes C++, the compiler just stops when you get so many errors because there's no point in going on. So even if we did fix this, once we fix this, we will see that these would cause errors too. Okay. So we've seen all of these declarations of objects. Objects have data members and methods or operations. The way you access data members is the same as structs. You say .x. Of course, you can only do this if month and day are public. And your rule of thumb should be that all data members should be private unless there's a really good reason to make it something else, just like in Java. Okay, to access member functions, if it's visible, you can say whatever object name dot method or function name and open close parentheses with however many arguments that you need for the function. Okay, so member functions, which we call methods in Java, must define or implement class member functions. You have to declare it and then define it, or you can actually, it turns out you can also do it in one step, just like in Java. Usually you don't, well, you see both, I guess. So here's what you do. You say public, and you usually put the public section above. You can do something like int get x, and typically you will just have the method or function declaration, and the definition can go somewhere else, but you can also put it right here as well. So this will be fine. And we can say, we can use set methods to void set x int, and I use a different name. You can, as if you're a Java programmer, you know that you can use the same name here as the data member, but then it can be confusing. You use the this keyword to remove that confusion. Double y in. Okay, so you can set it up like that, and you can put the actual method bodies elsewhere, but what I'm gonna do is I'm just gonna put it right here. So you can do it just like in Java. Return x. Okay. And I can return y. And I can do a set operation, x is equal to x underscore in, and y is equal to y underscore in. Okay, there we go, we're almost set, and now at this point we can say this lowercase y is an instance of this class y. And we're going to set x to 5, and you can say y dot set y to 2.543. All right, so let's save this. Compile it, and we have problems to fix, and I'll fix up these problems in the next video.